All right, you guys, this is exciting. We are in part 2 now of solving trigonometric equations. The last part, we focused on solving equations and finding all solutions. So we had this situation where if we're solving these equations, something like 2 sine of x equals 1. Let's kind of refresh our memory about how we would do something like this, finding all solutions of this. So, we found that sine of x was equal to 1/2. And because sine is a periodic function, we know that there are going to be an infinite number of solutions to this. So I want to find an angle whose sine is 1/2, positive 1/2. Well, sine is positive in quadrants 1 and quadrant 2. So, we talked about how our reference angle would be pi over 6. Wow. Now it's pi over 6. And then we need another angle in the second quadrant whose reference angle is pi over 6. And so that would be 5 pi over 6. And so our solutions for all of this, I would take that pi over 6 and I would add 2 pi times some integer, so 2k pi. And then I would also have 5 pi over 6 plus 2k pi, because anytime I add or subtract a multiple of 2 pi, right, I'm back where I started, and I have an angle that is coterminal with pi over 6 or 5 pi over 6, so its sine will be a positive 1/2. So the second part here is kind of nice. We are now, instead of saying find all solutions, we're going to restrict where we're actually going to find the solutions. So instead of maybe, saying that we want to find all solutions, now we're either going to find all solutions on a restricted interval. So on either 0 to 2 pi, or if we're going to do this in degrees, 0 to 360. So in that case, this makes it a lot easier actually, because now I just get rid of, well, let me increase the flow there on my eraser. I just get rid of this stuff because I don't want to go around an infinite number of times. I just want those solutions between 0 and 2 pi. So my solutions are just pi over 6 and 5 pi over 6. So it's actually pretty nice. I think it's a little bit easier when we restrict the range over or the interval over what we want the solutions, where we want the solutions to be. Sometimes speaking English can be difficult. I'm a mathematician. I don't always put into words. I don't always, put into words what I want to say. All right, so I'm just going to do a bunch of examples for you. That's going to be my goal here. And we're just going to do a bunch of examples. And I think this one, I know I've said this in the past, that I think this might be a little bit shorter. I think so. Maybe a little. I know the last one was like 40 minutes, 50 minutes. So I think this will be short. So I want to find all solutions find all solutions, but I want to find all solutions in the interval. Let's start off with degrees, and then we'll go to radians. In the interval 0 to 360. Now, when you look at this notation, notice I can include 0, but I don't want to include 360. The idea there is 0 and 360 are pretty much the same, right? So make up your mind. That's basically what that's saying. If you're going to do 0, you don't want to do 360, right? So 0 to 360. And let's start off with one that isn't going to be hopefully too hard. Yeah, let's look at this one. 4 cosine theta, and then we'll get harder, right? Equals 1 plus 2 cosine theta. All right, so I want all solutions, and let's find all solutions in this interval. Let's do part A, because we'll do a couple here where we want all solutions in the interval 0 to 360. So I have 4 cosine of theta, and I'm using theta apparently now instead of x, equals 1 plus 2 cosine of theta. So when you're solving these equations, just like we would in algebra, if you can, you want to get all of your variables on one side. As long as I'm not squaring anything, right, I'm probably not going to have to factor. And so notice I'm taking the cosine of theta. Both of my cosines are taking the cosine of theta. That's good. If there was like a 2 theta in there, I'm going to have a little bit more work to do. I'm going to have to use the double angle formula, but I don't. And then I also, I have only cosines. So yeah, and I have only cosines. I don't have a cosine squared or anything like that. So I'm just going to subtract 2 cosine theta from both sides. These are just like terms, you guys. It's just like if I had 4x equals 1 plus 2x. And that might be something that you could do if you're not sure where to go, right? Replace that cosine of theta with an x. And that's a trick that I think I used in that last one where we replaced like a sine of x with an m, or a tangent of x with an m. Replace it with a variable and see if you know how to solve that equation with that variable. Clearly, if I had something like this, right, I would subtract the 2x from both sides because I can get x by itself, and then I would divide. So that's exactly what I'm going to do here. I'm going to subtract the 2 cosine. I have 4 cosines minus 2 cosines. That leaves me with 2 cosines, right? And that's going to be equal to 1. Now let's just get cosine by itself. So this one's pretty easy. This one's just like the one I just did, except we're dealing with cosine. So I get cosine of theta equals 1/2. I want to find all angles, right, all thetas, in the interval 0 to 360, whose cosine is 1/2. So cosine, first of all, cosine is positive. Where is cosine positive? Cosine is positive in quadrants 1 and 4. What is my reference angle going to be? So my reference angle is going to be 60 degrees, right? The cosine of 60 degrees. So I need 2 angles. I need one in the first quadrant, one in the fourth quadrant, right? Who has reference angle 60 degrees. So the first angle is quite easy. That's just going to be 60 degrees, people. Now the second angle, so don't confuse this with inverse trig functions, where to get into the fourth quadrant when we dealt with inverse trig functions, we just put a negative. But notice, while if I did make this a negative 60 degrees, for sure the cosine of a negative 60 degrees is 1/2, but negative 60 doesn't fit within this interval. So the question asked me to find all angles between 0 and 360. So to find this angle right here, right, with reference angle 60 degrees, I still want positive angles. So what would that angle be right there? Well, we're 60 degrees away from 360. So it looks like my answer is 300. That's my solution. Aren't these great? I kind of love these. Well, I don't know. I really like finding all solutions. I feel like everyone's invited to the party, and I like it when everyone's invited to the party. So I probably overthink it a little bit too much. What do you think? Yeah, I think so. I think I'm, what is that word where you give non-human things human characteristics? I'm not going to even try and say it like we do it to animals a lot. I'm doing that with trig functions. Let's do another one. How about something like this? Sine squared of x plus 2 cosine of x equals 2. All right, so this one's going to be a little bit more complicated. Notice I don't just have cosines, and I don't just have sines. I have a sine squared and I have a cosine. Now the good thing is I just have x. I don't have a 2x. But we have to find some sort of strategy to solve this. When I'm looking at this, I can't really factor anything out. And anyway, it's not set equal to 0. If it was set equal to 0, I might want to do something like that. What I want to do here is I want to try and get this in terms of just one trig function. So up here, because I had it just in terms of cosine, right, I was able to get all my cosines on one side and kind of deal with it in that case. Whereas here, I don't have just cosines. But the good news is, and you're probably seeing this already, is that this sine squared right here, I can rewrite in terms of cosine, right? We know that sine squared is exactly the same as 1 minus cosine squared. And the reason that's going to help me is now everything at least is in terms of cosine. So because I have that squared right there, I'm probably going to have to factor. I'm probably going to have to do some sort of polynomial. It's not technically a polynomial, but some sort of factoring. But that's okay. At least I have all cosines now, okay? So I rewrite that sine squared in terms of cosine because I can't write cosine of x in terms of sine, right? It's not squared, so I don't have any Pythagorean identity or anything to deal with. So I'm forced to use that sine squared. So let's see what we have. Let's do a different layer here. So we had what? 1 minus, give ourselves a little bit more room, sine squared of x. It was plus, nope. No, 1 minus, I know you're probably yelling at the screen. I'm sorry. 1 minus cosine squared, and then I had plus 2 cosine x equals 2. So notice you have a squared. When we have a squared, we want to start thinking about this as almost like a quadratic, okay? So if I have a squared like this, how do we solve quadratics? We set them equal to 0 and we try and factor, or we use the quadratic formula. So I have the same thing here. So I'm going to rewrite this a little bit. I'm going to rewrite this as a negative cosine x plus 2 cosine x Okay, and then I have that plus 1, but now I'm going to bring the 2 over and set this equal to 0. And now I'm going to mess with this a little bit more, but for right now, what I want to do is, because I see this squared, I'm going to set it equal to 0. Now let's simplify a little bit. I'm just showing you every single step. Of course, you don't have to show, you know, every single step if you know how to do it. And now I don't like the negative in front, so I'm going to multiply everything by a -1 just to make this a little nicer. All right, now look at what I have. I have cosine squared minus 2 cosine x plus 1. If I were to let m equal cosine of x, look at what I would have. I'd have m squared minus 2m plus 1 equals 0. And I would solve this by factoring. Now, guys, you can use the quadratic formula, and the quadratic formula has a place in your life. And that place in your life is when you have a quadratic that doesn't factor. It is so much easier to factor this than to plug this whole thing into the quadratic formula. If you look at this, this is m minus 1, two numbers that multiply to be a positive 1 and add to be a -2. That's m minus 1 times m minus 1, or also known as m minus 1 squared. So I can do some of this side work. You don't have to do this side work. If you can see that this is going to factor into cosine of x minus 1 quantity squared equals 0, you know, you are more power to you. You are welcome to go just to this step. If you get to this step and you're not quite sure what to do, go ahead and make that substitution. Let m equal cosine of x and then see what happens. Maybe some good things will happen. I can square root both sides. Because it said equal to 0, I don't really need the plus or minus. This is pretty nice. We only get that cosine of x minus 1 equals 0. So I need all solutions between 0 and 60 degrees such that the cosine of x equals 1. Remember, cosine are your x values, right? So it equals 1 right here, and it would be -1 over here. And so what is my solution? All that work for nothing. 0. Oh, sorry. Apparently I got an email. I need to turn that off. All that work for nothing. 0 degrees. Okay? Isn't that great? That one was a fun one. Let's do another one. So we'll do one more in the 0 to 360, and then we'll look at what would happen if we weren't between 0 and 360. So let's look at one where maybe this doesn't always work out the way we think it should. So this one's going to be pretty similar to the one we just did, but oh, this isn't example. This is part C. Part C. Still solving this between 0 and 360. All right. So let's look at something like this. Secant squared plus 6 tangent of x plus 4 equals 0. We have the same situation, right? We have the situation where I have a mix of trig functions. I want to write one in terms of the other. So I know that 1 plus tangent squared of x equals secant squared, right? So I'm going to replace this secant squared with 1 plus tangent squared. And I have now a very, very similar situation to what I was dealing with, right, in the last one. I just want to do one like this because you'll see where I don't get the solutions aren't as nice as we're used to them being, and that's okay. So I'm going to combine some like terms here. This one actually works out fairly nicely. I get tangent squared of x plus 6 tangent of x. Combine the 4 and the 1 plus 5 equals 0. And then if you want, do that substitution where you let m equal tangent of x, right? But I can see right now that this is going to factor into something like this. 5 equals 0, right? I know I need two numbers that multiply to be 5, add to be 6. Again, if I did that substitution, it'd be m squared plus 6m plus 5, right, equals 0. And then I just substitute in tangent x for m. So we have two things going on here. I want all solutions to tangent of x plus 1 equals 0, and then I also want all solutions to tangent of x plus 5 equals 0. This should be a good time. All right, let's start with this one because this one's going to be a little bit easier. Tangent of x, I want all solutions between 0 and 360 degrees such that the tangent of x equals -1. Okay, so my reference angle right away I know is 45 degrees because I know that the tangent of 45 degrees is a positive one. So I know that to get a negative, I just have to put it in the right quadrant. I could not say my R's when I was a child, so sometimes I regress I can't help it. In the correct quadrant. How about that? That sounds a little bit better. Where is tangent negative? Tangent is negative in the second and the fourth quadrant, right? Because I know it's positive in the first and third. So I need an angle in the second quadrant here, whose reference angle is 45 degrees. So I know that that is 135 degrees. So that's one of my solutions. And then my other solution, I want to be 45 degrees. Well, it looks like I just add 180 to that. That makes sense. 45 degrees from 360 is 315 degrees. So there are two of my solutions. Again, I'm not going to add, you know, if I were finding all solutions, I actually would just take 135 plus 180K. But I don't want all solutions. I just want two solutions, those solutions between 0 and 360. Now let's look at this one. This one's not going to be quite as easy. We're going to have to mess with this a little bit. Tangent of x equals a -5. Okay. Now, I don't know off the top of my head, right, an angle whose tangent is -5. That's not one of our exact values for the trig functions. So you hear the click of my calculator. I am going to take tangent inverse. X equals tangent inverse of a -5. Now remember what tangent inverse is going to do, people. Tangent inverse is going to spit out angles between -π/2, here's -π/2, and π/2. So we have to be a little bit careful here, because remember I want all solutions between 0 and 360. So when I take tangent inverse of a -5, it's going to give me a negative angle, and that is going to be my reference angle. Tangent inverse, I'm going to make sure I'm in degrees. Tangent inverse of a -5 is a -78. Your calculator tells you it's a -78.69 degrees. Okay, that's not my answer. I want solutions, remember, between 0 and 360. Hate to tell you, but a -78 does not satisfy that, right? So we have to think about how are we going to figure this out? Well, if it was just tangent inverse of a +5, right, what that tells me is that my reference angle, if that was a +5, my reference angle would be a 78.69 degrees. If I take that angle and put it in the first quadrant, then the tangent of a +78.69 would be a +5. So I want to find then, instead of positive, though I want negative, tangent's negative in the second and fourth quadrant. So what I need then is I need an angle here whose reference angle is 78.69 degrees. So I'm just going, I don't know why I put my calculator away. I'm going to take 180 minus 78.69 degrees. And what do I get? Now I have an angle in the second quadrant, which is where I know tangent is negative. And I'm going to get x equals 101.31 degrees. Okay. Then I also need an angle in the fourth quadrant whose reference angle is a 78.69. Also, to get in that fourth quadrant, I could just add 180 to that. And so what is my other angle? 281.31 degrees. Or if you took 360 minus 78.69, I'm just making sure, we get 281.31 degrees. Notice both of these angles have this reference angle, the 78.69. Put it into your calculator. Now it's not going to be perfect. So if I put this into my calculator, I take the tangent of 101.31, right? I get a -4.999969358. Not going to be perfect because I rounded this number right here, right? But it's very, very close. And this is, and you might even round out a little bit further on that, especially if you're putting this into like an online homework system or something, right? You might round out a little bit further so that you're a little bit more accurate when you come to those final answers. I hope that makes sense. Is there a little tricky when you have to use the inverse trig stuff? All right, let's do I'm like pretty close to being done here, I think, people. Let's clear this out and let's look at other examples, okay? I'm just making sure that I'm recording. Okay, I was worried there for a minute that I wasn't recording. I think I am. All right, so let's look at, now, instead of finding all solutions between 0 and 360, let's find all solutions in the interval 0 to 2 pi. So a couple more and then we'll call it good. I mean, I don't need to, belabor the point, but I also realize that seeing examples is really good. Seeing all the different ways that we can kind of solve these equations, it's a good thing to do. So let's do, I would like to do one with like a double angle formula or something. So let's do it then. How about cosine of 2x plus sine of x equals 1. Ooh, this looks like fun. This is gonna be great. All right, so again, we have an issue here. One issue is we have cosines and sines, right? So that's always going to be kind of an issue if we have more than one trig function, because it'll be hard to just, unless we can factor something out, it's going to be difficult for us to get just one trig function by itself. The other thing is I'm taking the sine of x and then I'm taking the cosine of 2x, right? So this is where our double angle formula is going to come in. So our double angle formula, as you all know, and this is why I had you memorize the double angle formula, is because it tends to come up. The double angle formula for cosine squared, for cosine of 2x is cosine squared minus sine squared. So I'm going to rewrite this, even though it seems like it's making this a little bit more complicated. Here's the good news. Maybe you don't see any good news in this. But the good news about this is that now at least we're taking the cosine and sine of the same angle, right? I'm taking the cosine of x, I'm taking the sine of x. And the other good thing is, I know it looks more complicated and it's maybe a bummer that I got that cosine squared, but the good thing about getting a cosine squared is that I can rewrite that cosine squared in terms of sine. So I'm going to rewrite that cosine squared as 1 minus sine squared, and now I have hope, which is a wonderful thing to have when you're solving trig equations, right? Now, why do I have hope? I have hope because now I have everything in terms of sine. And even better, I can subtract 1. I see that those cancel, right? So I'm going to combine some like terms here. So what do I have? I have sine of x minus, and I'm going to combine those. I have 2 of them. And I just put the minus sine squared afterward. You guys, I have some issues. One of my issues that I have is I really hate starting expressions with negatives. So anyway, I'm just putting that negative there. You could have left that as a negative 2 sine squared plus sine of x. That would have been fine. This is great news, people. Great news. Look at what I have left. I have everything as a sine, so I'm going to factor this. I'm going to take a sine out of what's left. I would get 1. Sine divided by sine is not 0. People don't cancel it. Make it 1. Divide it. And then if I take a sine out here, I'm left with 2 sine of x equals 0. Okay, now I have 2 equations set equal to 0. So here I have sine of x is either 0 or 1 minus 2 sine x is 0. I think I got a little excited and didn't quite leave myself enough room. But this is between 0 and 2 pi. Sine are your y values. So where is y 0? Y is 0 at 0 and pi. So this equation right here is going to spit out 0 and pi. It's also 0 at 2 pi, right? But we don't include 2 pi. We're including 0 instead. Now here, let's simplify this a little bit. I could add the 2 sine x over and divide by 2. So what I have then, or subtract then 1 and then divide by a negative 2. All in all, we'll get sine equal to 1/2. So I know what is my reference angle. What angle when I take the sine of it gives me 1/2? That's right, it's pi over 6. And then where is sine positive? Sine is positive in the first and the second quadrant. So I want angles in the first quadrant, that's just pi over 6, and the second quadrant with reference angle pi over 6. So we have pi over 6 and 5 pi over 6. So 4 solutions that are just in that interval between 0 and 2 pi. Oh, that was such a good time. I really enjoy doing stuff like that. That's fun. Let's look at another one. I don't know, maybe one more. And then maybe that's probably good, right? So let's look at one more. I want to find all solutions again between 0 and 2 pi. And what if we did, what about something like this? We haven't really given any love to our reciprocal functions. So what about something like this? Secant of x times cosecant of x equals 2 cosecant of x. Okay, here's one thing that I know you want to do that you can't. Well, actually, you probably could with cosecant. That would be okay. But I just want to stress that we need to be really careful. I'm not going to divide both sides by cosecant. Now cosecant's special, so not special, but cosecant's never 0. So I actually could divide both sides by cosecant and be okay, but I don't want you to get in the habit of that. What I want you to get in the habit of is if you see something like this where I have something that's a common factor, what you need to do is set that equal to 0, okay? And notice I have two different functions, two different trig functions, but I can't really easily write secant in terms of cosecant, right? We just can't really do it. Secant's 1 over cosine, cosecant's 1 over sine. I don't have any real relationship between them that would allow me to do that well. So what I'm going to do instead is I'm just going to factor out a cosecant here. So I have a cosecant common to both terms. And look at that, that's really nice, right? So now, again, if you can factor, a lot of these are going to be factoring. I have it set equal to 0. That gives me some power here. So this tells me that solutions to this equation are going to be any x's that might make cosecant x. We're going to see that's not true. Or we can't do that. That's okay. Or any x's that would make the secant of x minus 2 equal to 0. I think I said equal to x here. I meant 0. So let's look at how we're going to deal with this. Remember, cosecant of x is 1 over sine, right? So this equals 0. So the way I would want to solve this is I would want to take... I'm like making hand motions and you can't see me. But I would want to flip both sides. So I'm like using my fingers to flip. So to flip both sides, right, I would flip this side. That would give me sine of x then would equal, but you guys, whoa, I don't know what I did there. This is 0 over 1, really. If I tried to flip this side, I would have 1 over 0. Ooh, I don't even like writing it. It like gives me the creeps to even write 1 over 0. I can't do it. I can never find an x value in any universe that would make the sign of it become 1 over 0, right? I just can't get 1 over 0. And so this equation right here, there are no x's that make this equation true, so we just don't get any x's from this solution. So no solution for this side, and that's okay. That doesn't mean I have no solution to the whole equation, because I still have this equation right here to work with. Here I have secant of x equals 2. So if you don't know what angle gives you 2 when you take the secant of it right off the top of your head, let's rewrite secant as 1 over cosine of x. That equals 2. And then let's flip both sides, which we can do. Cosine of x, then this is 2 over 1, must equal 1/2. And now we have something that we've already dealt with, right? We know that where is cosine positive? It's positive in 1 and 4, right? What reference angle am I going to have? 60 degrees, which is pi over 3. So pi over 3 is going to be my first solution. And then I need an angle in the fourth quadrant, right, whose reference angle is pi over 3. Well, 2 pi is 6 pi over 3, so I'm 1 pi over 3 away from 2 pi. So my two solutions between 0 and 2 pi are pi over 3 and 5 pi over 3. All right, guys, I think I've done kind of all of the type of examples that you're probably going to see. I really like doing these. They're fun. That doesn't mean you do, but I hope that it doesn't cause you pain, right? That's my wish for you, is to do math without pain. All right, let me know if you have any questions.